Small connection problem.
Добрый день.
Hello, I'm Pavel Dovbush. I work in the Badoo company. I'm the head of the front-end department. I would like to tell you about how do we monitor the site opening, the feedback from all our users, and we have 100 millions of them, and right now, just recently we switched to this big threshold. It's not a secret from any one of you that the speed of the site is not the final, it's not the last thing that we should take in consideration. There's a lot of practices and ways to optimize requests, to optimize site opening speed, a lot of books about it, a lot of articles. It's not my presentation, but briefly I will touch and tackle this topic. There's a utility, Google Page Speed, which assesses how fast is your site. And perhaps this picture is well known to all of you. Your requests don't content loaded when your application starts initializing, that everything is available. Unload when everything is downloaded. It's not any use to any one of you. The recommendations are mostly aimed at optimization of the size of the entrance and HTTP requests. The reduction of HTTP requests because it's time, so that the summary time would be smaller. DNS requests because DNS is a time for resolving of names, caching, then zip, minify, gzip, uniting several files into one. But all these practices, you need to approach them with being careful. It's not always that you have to put everything in the same file, because if you have a library for all pages, then perhaps it will be useful to connect it as a second file. The same thing with the styles and other techniques which you are well aware about, so I'm not going to elaborate on them in more detail. So we have followed all these recommendations. Golden Page Speed shows us 100 out of 100. Everything's all right with you, but is it enough for us? Is there anything, maybe there's anything else that was not considered in those recommendations, what was not shown in the reports? We didn't came into consideration initialization of the application. We all put our processors on DOM content loaded. There could be a lot of them. They're sequentially being initialized when this event comes. And the realistic application is going to work on the side of the user, not at the moment when we had the document load, but when all scripts were initialized. So respectively, usually they produce this thing. At the time of JavaScript initialization, we call it JSON. It can be very significant. And in some projects, it could be comparable to the time of networking part download. So what is important to the user? Of course, not Google Page Speed rating. The reaction of the site is important to them, how fast he sees and how fast he can click. He sees it at the moment DOM content loaded, and maybe through JS we'll put it even a little bit later, and this time usually is being ignored. And then full page load, when all pictures are available, nothing rotates, nothing loads, and everything is working. So what is important for the developer? For the developer, it's important to understand how much time for real users it opens. So we've looked at fair bugs, it's 1 second, everything's cool, but what really happens on the side of our users? We don't know. So we have a big project right now. 2 platforms have 150 million users from all countries, whole Europe, Latin America. We come to American market, therefore we have a lot of different users with different hardware, software, internet channels, and we want to know how this application works for these users. And as you can see here, how can we see the real effect from what we do, from doing certain optimizations? And achieving 100 out of 100 from Google Page Speed. Users, they do it just by first impression. If it's not slowing down, it's normal. But for the developer, it's not sufficient because every users have different internet, different hardware. And we can use, for example, the old computer. One can use old computer to see how your JavaScript is working on the old hardware, which is not really powerful. And especially when small mobile devices have appeared, it became very important because many have nettops and other devices. And in our company, we had a case, funny experiment, where the nettop, very weak Sony machine, it was 4 years ago. And when we have entered internet site, it started overheating, coolers started making buzz, and it was not really good. Users were not happy when the device, only with your side, is getting warmed up. So how else can we understand is everything all right with you or not? It's artificial tests, some kind of synthetic tests of certain cases. For example, this could be several years ago we paid attention to selector engines, and this is a test related to selector engines, so that if it works faster than in old browsers, everything's going to work all right. Speaking about tests, however, we don't know. Tests usually close very small gaps. Small synthetic test tells that it's better to do it this way here. But we don't know how much of a real benefit some optimization efforts will give us. For example, replacement of selector's engine. How much it's going to give us? Should we spend some efforts on it? How else can we look at it? We have these data reports which are not Firebag on your computer, but service, and the URL is very small, page test or good service. From different places, from different browsers, you can order how realistically a user-generated page looks like, but they don't take into consideration the JS time initialization, only the networking part. Useful, informative, you should enter and look how it works, how it looks from dollars in EA8. There's another service, Gomez Network. They decided to make a step forward, and they provide monitoring on the same level of reports, but drafted from different locations, geographically distributed systems, so many providers have their own equipment which makes requests from these providers all over Europe, several dozens of locations, and all over the world as well. And the second thing they propose is a test from real users' computers. Some users, test users, or they're paid for this, I don't know, they install certain plugin and you can see how it looks inside of the user. Very useful service. It gives you the picture, especially these two peaks. In the beginning, these were certain networking operations, so everything was much slower. Well, it's nice to show this particular image from the backbones from the service located inside of providers. And I'd like to start speaking. Well, it takes about 1-2 seconds for the full time of page load. When you click on this point, it's not obvious where these points are located. The report will be for specific measurements. So the same data that you see here, but only with more points and serious monitoring. But once again, we come to certain data, and there is no time of JS execution. The JS time, execution time depends on the hardware, not only on the networking part. But everybody understands that. So what do we do? What do we propose? To measure ourselves with our own hands. Some things that we want, things so that all applications are written differently. Some numbers we need in the beginning. Some of them are asynchronously loaded, some of them important, some not important. Why? On all these graphs, you don't see the same line like it was said previously that everything's ready. Because all applications are different. So we make, and I would like to propose you to do a very simple system. Measure yourself. Measure real users. So what should be measured? First, a general picture. how long scripts are being loaded, when the application initialization begins, how much time it takes for initialization when everything's downloaded. You measure it from our real users who use our internet site, so we see the full picture. And how they should be measured. I was thinking, should I include or not the simple examples? And our example scripts we turn into 2 timers, and then we receive load time and the time for JavaScript parsing. If there is certain math in here, it will always be in this dimension. DOM content load event started in the beginning of the document. It's obvious. And for the unload, the same thing, it's all obvious. So, how can we measure the time of application initialization? It's the most interesting part. That's what my presentation is about. Your architecture should allow you. If you just have simply connected sets of third-party libraries, unstructured code, then you won't be able to measure and receive some clear picture about it. But we have only one entry point. A little later I'm going to show you how it works, but it's a DOM content loaded where we can put 2 timers and learn about this time. In the worst case, you will have to process it separately. How does it look? You have certain pages array. What is a page? Separately, event and DOM content loaded, begin. All pages are initialized and is the end of the application initialization. They don't take into consideration some asynchronous things, asynchronous load of components which will be needed later, but it's understandable why, because it's most important. Page, we use OP actively, and this one is the simplest one here, the simplest implementation, because there's a basic page cloud, which is not doing like that, but he collects all pages, it collects all pages, all classes, which are inherited from page, and it's the part of application which works on all clicks and all logics. So he collected all of it, and all of them, they are initialized here. So we receive total time of application initialization. After this, everything works good. We have no code which makes it differently. But we collected information that we need. And how should we collect? Because 150 million users, about 30,000 requests, and to the side about 10,000 requests per second for the backends. And we need all this information, big amounts of it. And we can do IAG requests. It's too stupid. We can do as a Google Analytics with hidden image. Hidden image, we create an image for some URL and give all the parameters to it. So there could be more parameters if we need to measure something else. Why not Ajax? Because we don't need status of this request. We don't need any reply from it. We just want to drop data. The second option, because it's statistics, because we're a lot of data, we don't need guaranteed delivery. In other words, we can allow ourselves to use just a cookie. And everybody knows that the cookie is connected to the next request and goes to the backend. So user have opened the page, we have calculated, put it in the cookie, next auction, whether it's a Ajax request with some data, or maybe transition to another page on the back end, we can read this cookie. So we have non-guaranteed delivery. If he has closed browser, then the last value is being lost. But it's not important to us because we have a lot of data anyway. We don't have extra orders for data, because if you do Ajax with hidden image, you get as many requests you have, so many requests with statistics. It's clear. And even Google Analytics, in case if we'll join them, it will send us letters, please reduce traffic or pay much more money. So the load is very serious. And in cookie, we don't do any load. The collector removes the cookie in order not to have copies thereof, and to reduce parasite traffic on requests which are not page transition. Well, collecting data on the page, as I've told you previously, we have a lot of data for such a big volume. It's a separate complex objective. It was solved by our colleagues from platform department, but I'd like to briefly tell you how to use it. Scribe is a Facebook open source project to collect logs and other data from a cluster of machines. The aggregation is done in MSQL, then we build graphs. So how the aggregation happens, a very rough scheme. So we have users, we have a cluster web machine, which processes dynamic requests. At each of these web, there's a scribe agent. When they put events, a scribe event guarantees practically 100% delivery of this event into Scribe Central. Scribe Central is an aggregator of all logs into Scribe, in the Scribe. For us, it's one machine for every platform, even though on these words I'm not really confident, maybe it's even more than that. So they do PHP scripts which even stronger, in a stronger way, aggregates data and then automatically put them in this SQL database. Notwithstanding the fact of aggregation, there's a lot of data. At a certain amount of time, we could see 6 of those per week. So these timers, load, don't contain load, fulfillment of JavaScript, loading of the script, and unload of the script. Then divisioning by the browser, by the country, and some other data. So there's no data, not much data right now, but due to the fact that requests are in big volumes and we should think about it seriously. So let's go to explain what do we see in the picture, because I think you don't see very well those graphs. So we use logarithmic scale in order to identify big peaks so they wouldn't cover normal picture of normal browser. That's why I was surprised that there will be 100, 200 seconds, etc. So on one graph we measure time, and I was speaking about initialization of JavaScript, and it's the most interesting application here. Then we divide them by pages. In one graph there will be by country distribution. That's how it looks like. So this graph is a very old one. These are results of optimization of the profile page, and if you look here, with 1 second we have reduced to 100 milliseconds in all browsers from 1 second. So it's 10-time optimization. Why do we have so many zeros in the end? Not because we're able to optimize everything to zeros, but because the graph was kept for some prevention works. But honestly speaking, it was difficult to find graphs because the system was implemented a long time ago. We already detected most of the shortfalls. Peaks are more than 100 seconds. And back then we didn't have that validation, and we didn't have the filtering of non-correct data. Well, that's another example. What kind of a page is this? I don't remember. For some company we've been doing the optimization. Usually on the page, as I've been drawing it before, there will be another graph. We have a lot of components. Some of them are done fast. Some of them take a lot of time. So something was optimized here, not bad. From second to 250, 300 milliseconds, depending from the browser. So this is all real data. It was done. It was giving us effect on all our users. All these graphs are aggregated from all over the world, from all our millions of users that we have. What else can we see? Errors in the side of the browsers, and in more particular, if something went wrong with Internet Explorer families, with all other browsers it works alright. Same thing would be if the testing department have omitted something or missed. So it's a graph. You can see when the time for application execution was changing. Well, the graphs are almost linear. In the beginning this was some incorrect calculations. As of June of last year, we shouldn't pay attention, but was happened in November. The drop, we have simplified the logic of the page, and it gave us such a good effect. The same graphs could be in other directions, giving a lot of new functionality to the page. Everything just jumps up. Well, so right now we have received general data from all users. So how does it look for all our million users? For example, we're not really happy with main page image because we have 100 million seconds and we don't like it, we want to do it faster. What should we do? On the page, maybe it's not a good example, but it's very simple. For example, on the profile page, there's a lot of logic involved. A lot of components, each one of them is responsible for some part. Which of them is giving the highest hassle to us? And because we have a lot of general data, we cannot measure by components from all users. We make these measurements on some test users, on staging. We can make reports for the component. We can add the dimensions that we want. Then, same graph. If the first type of the presentation I was speaking about the big pink square, initialization of the whole application, right now we're going to speak about the small squares. How can we change the initialization time for specific components? Well, the same function that we've seen in the beginning on a DOM content loaded, but we don't measure general time, but specific component is being measured. It is possible thanks to our architecture of application that we have a point where we can measure everything. Therefore, we get some high-level profiling, not a number of calls and time of calls of certain function that selectors take most of your time in the application, but which component and how long it took to initialize it. So by reducing the initialization time on the inside of this component, it will be much easier to clean and to profile it and make a decision that this has to be rewritten, and this, because we can't spend too much time, this should not be rewritten. So it's some kind of a motivated in numbers for your own boss that this has to be changed because it's bad, and here are the numbers. Well, this is one of screenshots how it looked many years ago. I kept it just because I was really impressed how by 1 out of 22 components we can make 5 seconds of time plus 5 seconds of page initialization V6. It was several years ago. We've been supporting it. One component, 4 seconds, Flash Fox 2. Half a second. These were 80% of the market, so there were no other browsers in the market, so we have been easily able to see what is the problem on our side. So we have changed it, and one portfolio, this how the optimization went. Well, monitoring. Usually, what do we have in the system right now when you don't do any works on the networking equipment, which also plays its role? You see even lines. 6 terabyte of data, we build a lot of even lines, and it's cool because we see that in our application everything's all right. We don't have any problems. If some traffic peaks, we can immediately see them. Therefore, the initialization time is approximately 100 to 250 milliseconds for this specific page, and many others. This is just an example. To 50 milliseconds, it's E6, 7, and Firefox 2. Well, not really important browsers to us because market share is very small. In all other, 100 milliseconds. Well, graphs. Is it a standard system? Well, it's a standard for us, but for some of you it's not standard. We divide certain graphs for days, weeks, months, years, because this graph depends from the week. If you compare certain output, you have to compare it not with yesterday, but with the same day last week. And when you divide graph like that, it's easy to do actually. The same we divide by pages, by browsers, and by countries, because we have a lot of different countries. The picture could be very different in these countries, and that's another important information. But unfortunately, isn't anything is visible or not. But if it would be smaller, nobody would see anything. All these measurements are, well, you can see if DOM content loaded have increased due to some networking problems, then you will immediately see unload and a correlation between timers and vertical location. And the final graph. We have two data centers in Prague and Miami. This is a graph for all browsers in France. From left to right, distribution by percentage of on the time of page installation from 0 to 0.5, from 0.5 to a second, etc., etc., upwards. So you can see that in France, in the first two, under a second, we have only 80% of the traffic. It's very good. It's very cool. Everything's all right in France. Let's compare it to Brazil, and the other data center which is closer to it, to which many of companies coming, and we see that not everything's so bright on their side. Yeah, it's cool that we see it thanks to this data. The second thing is that the problem, not specifically to your application, because we have the same code in all the places, because we don't make the code difference between Brazil and France, but the problem is in network connectivity, internet in the country, some hardware in the country, and this also allows us to fix this data. And a final slide, development plans. In modern browsers, we have API, which gives us more networking operations. So, how much time a DNA request have taken, and how long he was giving the answer. It was also a very interesting information for networking engineers. And most of this information will be available in the browsers, will help them to understand where the connectivity problems in specific countries and specific users. We also would like to develop the analytical directions. We want to draw more graphs in order to see more of interesting things. Thank you. Questions? Thank you for your presentation. Can you tell us, please, is there any consortium solutions ready, box solution? I was telling you about the methodology. Everything depends on your application. I don't know how it works. Therefore, you have to decide where your timers, where the application has been completed by initialization. Everything depends on and the work can be written. It can be put in the open source, and you can have several functions in it, like beginning of the initialization, end of initialization, or beginning of the component initialization, component end initialization. It can be done in the browser. Even though if it takes text from the report, you will understand what has to be written to write this fragment. But Pimba solves the same problems only for themselves. Pind is a backend. For the backend, we use Scribe. Scribe is an open source solution. You can use it. Thank you. Well, I have a question. In the beginning of your presentation, you said that you were involved in profiling selectors. So, I have a question. You said about the methodology, but what have been optimized by you? You went to selectors and how to simplify and speed up the work with them. Have you tackled anything else? And what specific components of JavaScript? And question number 2, you have profiled your scripts, but have you used any internal profilers like Farlags or something like that? The execution time for every function, have you compared them? Have you seen any differences? The answer to the first question, this graph was found yesterday on jspref.com, the first that came to us. It was just an example of how can we compare some things. As for selector, we have our own selectors engines inspired by JAS, the first version, very first version. Unfortunately, I don't remember the author, and he gave the proof of concept. How can you quickly make easy selectors? We use CC1. You can do it in Cola. As for optimizing inside the company, in my presentation I haven't mentioned how the techniques can be used to compress files, how can you unite them into one, because there's a lot of this information in the same books. They have examples of how can you optimize your GS, what have you paid attention to, what should be paid attention to. Yes, we do have an interrelation DOM a la selectors with initialization of the page to a certain component, but several years ago, 4 years ago actually, we did have such problems. But We've been solving it not by speeding up selectors, but by transferring of samples, not during initializations, but when we really need these elements. Event delegation, nobody canceled it, everybody knows about it. Same thing about relisting any specific class. You can take these questions out of the house for later and keeping all the necessary things. What else have you optimized? Well, it will be discussion about our architecture and we won't have enough time. But we have optimized the system. I gave you a presentation how we've been systematically looking for a problem and systematically we're optimizing it. But profiling, yes, when you discover specific place which is of interest to you or a specific component and it can be separated and it can be profiled separately. Therefore, profiler utility gives us SBAC and everybody knows about that. Yes, of course, we use it. I don't know what else can we say. Well-known utility. I have the question about external dependencies. You have a lot of them in your project, like jQuery or something else. And if there's a lot of them, how do you profile their work? Because it's absolutely unpredictable query. And at the same time, to build modern website without certain frameworks additionally or libraries, it's a very costly job. I agree to you, because historically it did come out that in Framework Protect.js and the initial profiling of it have shown us that during those years, it was in the year 2008, it was roughly speaking not really good, but there also was, still have time? Yeah, a couple of questions. Yeah, well, to give you the story, we did an experiment. One landing page, we put this framework there, and then we measure how much we get from the conversion point of view, how many users move on. So we have received plus 150 to 100% of conversion, so it became the main priority for us to rewrite in such a way so that these problems would not appear. So we have figured out that thanks to this system, we have understood that prototype is not sufficient. We need something else. Therefore, while transiting, we've been measuring these components. We've tried to minimize using dependencies. So the transition took very long time in the course of 1 year, but without stopping the production. So it was only part of the time used, but at a given moment of time, we don't have dependencies. Why? Because if we take the history.js that we need right now, it weights like the whole framework plus all framework for the site. It's a very heavy, big risk. Maybe we'll undertake it, but it's a very big risk, as I've told you. Therefore, it is more effective for us to write some things from the scratch. Including we've tried to take certain components, we've discovered certain mistakes in some browsers that we need, but we know the others of the components, so it had to be rewritten. So there's a lot of things from Aspire, but the total code is ours. After it was forked, nothing was left after it. Forking bread type was an interesting project. We did something like statistical analysis of the code, how much of functions from the prototype is used in our code. And we figured out approximately 100 things. And how often did we use them? And we figured out that out of them, 30 we use 100 times, and all the remaining 70 from these 100 that we use only once. Therefore, the framework use is a common situation for all projects, and we have figured out that these 30 by function, we need them. We did it as our separate framework, and everything else, either some utilities that solve for specific cases, or we could change it into something else. So the prototype form, we didn't require it. Have you used the testing, A/B testing? A/B testing? Yes, we had an attempt to start a Google Web Optimizer to try it on it. Unfortunately, to the structure of our project and what Google Web Optimizer proposes, it didn't work for us, so we had to hack their code and not use things they want to use, but sell them data for analytics. They send them the data they don't expect, and we have figured out that we felt didn't not convenient. We have done experiment plus 20% conversion for a specific page. However, it took us very long time on the developer side for the use. Right now we do an internal system, our own system calculated into our problem, so it can be built deep into the nucleus, and it will be our own self-written API directive. One of the teams is involved in it. I have the following question. Generation of the debugging on the side of the client, does it justify itself or not? It's a complex issue. Yes, we use it, but we can't say that we use it widely. We have to say that all templates on the region, we use the simple regularity which supplies the variable. It's natural that it's much better because templates are they have very complex design because everybody wants to have circles. The template comes from the server in Ajax request or it is written directly in JS files. And the templates are used, but we cannot say that they used actively but significantly. The time with these templates, is insignificant, so we can use it, and this is all okay. But we have a very complex application, different business logic for different countries and user categories. And to put business logic of building the user information in the client side, it will be a big amounts of code and big amounts of templates. We cannot do that right now. So it is possible if we'll compare it to some other projects like Gmail. We don't use simplification of client on the client side. I had the following question. Some measurements on the side of the client, and the cookie could be forged. So do you have any traffic from jokers, so-called jokers? How do you fight against them? With a project of such a scale, you cannot go away without those jokers. With 10,000 requests per second, you will always find somebody, some inquisitive guy who will look for bugs or for problems or gaps. Because it's a statistical data, because on those graphs that we see any words that we expect, for example, we expected this drop and we were able to see it. So in percentage ratio of this traffic is very low because we filter out by the data format that it has to be proper and by very big and very small numbers, and we throw them away as well. In other words, some targeted protection we don't have. But if you in your browser you will put the cookie return always 100, 100, 100, you will destroy our statistics a little bit because we have 150 million users and this is not too bad for us. Thank you. Let's try to ask the final question, and I see the lady, she raises the hand, or the young guy, I don't see it from such a distance. Can you give him or her the microphone? The question is the following. Ajax requests, they also transfer cookie, right? So do you clean it after yourselves when a person makes an Ajax request, or you constantly send it until the person goes to the second page? On the back end, we have all the pages inherited from some base class, roughly speaking, web page. Service page, which processes Ajax, is inherited from web page. Web page has a processor. No matter what request it is, it looks if there is a cookie, it sends it into Stripe and removes it. Requestively, the first Ajax request will take away this cookie from you, and all following Ajax requests and transfers of this cookie, well, this cookie will not be available there. Thank you, Paul. Thank you. So, I will make a small suggestion. When Robert will finish his presentation, there will be lunchtime, and you have your lunch ticket in your badge. Don't forget about it. We eat in Progress Bar, so it's not too far away from here. Well, I don't even know. Do we need to introduce Robert, or maybe some of you knows him, what he does? Robert works in Mozilla, and he does the evangelism of an open platform on which they work in a corporation. They're involved in open standards, questions, and many other different things. Yesterday we have briefly discussed all of it with him, and I can say that you can speak with Robert on any topic, and not only related to development. So, Robert Neiman, let's welcome him.
Okay. Yep. Just. Oh. Yep. Okay.